So we're going to start by taking a look at what exactly Android penetration testing is, and just getting a general feel of how penetration tests are usually conducted, so we can get a really good idea of what we're really trying to do as we start to jump into the concepts of this course. So the first question that we'll ask is, well, what is a penetration test? The main goal of a penetration test is to simulate an attack on an application. So we're going to pretend like we're an attacker, and we're going to go and try to find some issues inside of the application itself. And there's three main types of penetration tests that we typically see. There's opaque box or black box, a semi-opaque box or gray box, and then transparent box or white box. And each of these basically differ in the way of how much knowledge we have when we're going through the penetration test process. So for example, in an opaque box type of penetration test, you generally know nothing about the application at all. All you have is the application, and you're just going in with absolutely no sort of information. This sort of attack simulates the way that an attacker would go about attacking an application. They would know nothing at all, and they would just jump right in and try to figure out if there's any sort of issues. A semi-opaque box means that you have some amount of information. You may know a bit about the architecture of the application itself. You may be able to see documentation, this type of idea. So it gives you some amount of information, but not like a huge amount. So you have a little bit more than an opaque box, but maybe not all the information available. And then a transparent box gives you literally everything. You have access to source code, binaries, you may have access to the servers the application uses. So you have access to literally everything, and this would give you the best chances of finding issues in an application. Now, which kind of test that you're doing really depends on who you are related to the person who made the application. So for instance, if you are internal to a company that builds an application, you may be doing a transparent box test because they can trust you with all of the source code, all the binaries, all the access to the server, all this sort of idea. Whereas if you're external to the company, you'd typically be using an opaque box. You'd have no sort of information. The company's not going to expose to you all this internal information, so you're going to have to work with what you're given, essentially. So you'd be more in the opaque or semi-opaque box. As we're going through this course, we're primarily going to be focusing on the top two, because generally a lot of the techniques will carry over to when you have information, but in a lot of cases, you're not going to have the information. So I want to show you how to do things without a huge amount of information, and then when you have the huge amount of information, it will just be easier for you to do the things that I teach you in these videos. So that's primarily what we'll take a look at. Now, what are penetration tests really looking for? As I said, they're looking for issues, but primarily the main issues that we're looking for are things called vulnerabilities. A vulnerability in an application is a weakness in that application. And the weakness needs to cause an impact to at least one of the following things: confidentiality, integrity, or availability. We call this the CIA triad in security. Confidentiality deals with the idea of data being confidential. So for instance, if you were to give an application a password, maybe some personally identifiable information like your phone number, your address, maybe payment information like credit cards, this type of idea, you would expect the application to keep that confidential. You wouldn't want the application to tell anyone that information. If an attacker could find a weakness in the application that lets them gain access to someone else's sensitive data, that would be a breach of confidentiality, for example. With integrity, we're taking a look at the data actually staying the way that it's supposed to without being modified in some sort of way. So for instance, if you could modify someone's password to make it weaker, if you could modify someone's transactions to make their bills more expensive, if you could delete things off of a user account, those would be examples of violations of integrity. It's modifying data that you shouldn't be able to modify. And then availability just looks at the ability to access the application. If you can prevent a user from accessing or using an application, that would be a vulnerability that impacts availability. So generally, we're taking a look at the idea of either being able to gain access to data we shouldn't be able to, modify data that we shouldn't be able to, or to be able to prevent someone from using an application the way that they want to. Those are the three main weaknesses that we're looking to exploit in a penetration test. Now, if we manage to exploit those, how do we determine how severe the vulnerabilities are? We typically use a scoring system like CVSS. CVSS is the most common one that I've seen. There are some other scoring systems, but this one usually is pretty standard. And I'll show you generally how this works through the calculator that is provided through NIST. So we'll come over into our browser here. We'll pull up that link that I have inside of the spreadsheet. And we'll see this nice little calculator, and we'll just walk through the idea of what we're looking at when we're creating vulnerabilities in applications. So we want to have a good understanding of the following things inside of a vulnerability. We want to understand the attack vector. How do we actually manage to exploit the vulnerabilities? So how are we able to cause the vulnerable behavior? And there's four main options that are provided here. So network would mean that we could just send things over the network in order to cause the vulnerability. Adjacent network means that we have to be essentially on the same network as each other. So you can see here that it's limited to like a shared physical space, things like Bluetooth, local IP settings, these types of ideas. Local means that we have to have actual local access to the actual device itself. So that means that we're actually able to get them to do something like, installing an application, for instance, and we could use our application to exploit their device or something like that. And that might be a local kind of vulnerability. And then physical means we actually need physical access to the device itself. So I need to actually physically have someone's phone in this case to be able to exploit this kind of behavior. And each of these essentially has a severity to them. A network type vulnerability is the easiest to exploit. This would give us the most severity, whereas a physical type vulnerability is much harder, right? In order for me to get physical access to a device, extremely hard. So it would lower the severity of the vulnerability respectively. So for example, we'll say that we have a network-based vulnerability. Now, the attack complexity tells us how hard it is for the attack to actually be done. Now, the complexity is always a little bit tricky. We're not really necessarily talking about, how many steps there are or, how hard it was to find the vulnerability. What we're talking about is how consistent the vulnerability actually is. So if you hover over high, for instance, you'll see here that the successful attack cannot be accomplished at will. So it can't be accomplished just, the attacker wants to do it, so they do it, it's no problem. Usually there's some sort of effort required. Usually there's maybe some sort of like randomness to it. They may need to time things in a particular way. There's something that causes the vulnerability to be less reliable. Whereas a low attack complexity means that, pretty much in every single situation, we can get this vulnerability to happen and there's no sort of issue. Of course, a low attack complexity is much higher of an impact. It's much harder, or it's much easier for us to exploit something like that. So it'd give us a higher severity. So I'm going to say, low as an example. Privileges required is going to tell us how many privileges we need in order to actually exploit the vulnerability. So we're taking a look at Android devices. There's a few different options here. So a privilege at none would mean that we don't need any special sort of privileges. It means that we don't need to import any privileges into our application, for instance. The user doesn't have to be running like super user or anything like that. There's just no sort of privileges required. A low level of privileges would mean that we need some basic user capacities. Like maybe we need the ability to store files, in the external storage of a device. That might be a low level of privilege that may be required, right? It's something that we could attain pretty easily, but it's not really, that we have no privileges. It's that we need some, but they're easy to obtain. A high level of privilege is like you need to be a root user or a super user on the device, something like this, right? So if you need a high level of privileges, then this is going to in turn be a harder thing to actually exploit. A lot of the time, Android-based vulnerabilities are going to be low or none in terms of privileges required. So I'm just going to say none as an example. User interaction tells you if the user has to actually interact with something in order to be exploited. So for instance, if the user has to go into their browser and click on a link in order for the exploit to happen, that would be an example of user interaction required. So if the user has to do something for the vulnerability to happen, that means that there's user interaction required. If the user doesn't have to do anything, so for instance, they just open up their app and the vulnerability happens, then there would be no user interaction required. Of course, no user interaction required is much easier than user interaction required. So if the user interaction is required, it's a bit less severe in turn. And then finally, in terms of our main exploitability metrics, we have scope. Scope determines whether the vulnerability is going to allow us to get an increased scope of the device. So for instance, if I could compromise or cause a vulnerability in an application that then gives me access to other applications or gives me access to the system as a whole, that would be a scope change. I'm no longer just inside of the app itself, I'm actually beyond the app. Whereas if I do something that only keeps me in that app itself, it would be an unchanged scope. And oftentimes we're going to have an unchanged scope in Android-based vulnerabilities. However, in some cases you could get a changed scope, and those are really severe based vulnerabilities in the case of Android itself. So if we could actually change scope in order to get something beyond the authorized privileges, that's something that is typically relatively substantial. And then the final three things that we have here are the impact metrics. These determine how much of an impact there is to the three things that I was talking about: confidentiality, integrity, and availability. So you see that there could be no impact to them, there could be a low impact, or a high impact. So just to give you a bit of a context around these, because they're fairly important to understand, right? A low confidentiality impact would be that there is some loss of confidentiality. So it's not like a direct, serious kind of loss, but just like a little bit of confidentiality loss. Like I'd give you an example. If I could leak user emails out of an application, I would consider that to be a pretty low loss of confidentiality. Generally, an email is a pretty publicly available thing. If I gain access to emails, there's not a ton that I can really do with that. I can spam people, I could sign them up for things. It's not really that big of a deal, right? So that would generally be a pretty low confidentiality impact. A high confidential impact would be something that is very substantial. Like if I could leak credit cards from an application, totally different story, right? I could charge their account. That would cause a really serious impact to those users. So that'd be considered a high confidentiality impact. And before I go into the other two, I will just note that this is something that's kind of subject to debate. You could debate and say that emails is a high confidentiality impact. It's really just in my opinion that it's low. So there is some room for discussion there. If you can justify that as a high impact, then go ahead and justify that, and that's totally fine, right? In your situation, it may be a higher impact than in the situation that I'm discussing here, right? It really depends around the context. If you could leak the emails of important people, then maybe that's a bit of a higher impact, right? So it's really situational, and there's a lot of discussion around those sorts of ideas as well. So for instance, let's say that we found something with a high confidentiality impact. Integrity, like I said, is the ability to modify data. There's low integrity impacts, which means that we can modify data that, again, doesn't really have a serious impact. Like maybe I would be able to change a user's address in their profile. That's not really like a huge impact. It's kind of inconvenient to the user, but in a lot of cases, it's not going to be like a huge impact unless maybe it's a application that ships things to someone, in which case, if we change their address, we could ship it to us. That could be a higher impact, right? So like lower impact is this sort of thing. Maybe we can like change the user's log files. That sort of idea. Typically going to be a bit of a lower impact to integrity. Whereas a higher impact to integrity actually would be like an example, like if I could change someone's address and it's something that ships things to that person, then I would get the things shipped to me instead. They would have a pretty serious impact out of that, right? Other examples that we could have is maybe I could delete a whole user's profile. That would be a pretty substantial impact overall, right? So we could have a higher impact or a lower impact, or we could have none, right? Maybe we can't modify files at all. That would be a generally low impact as well, or no impact rather. So availability is our final piece here. Availability is going to be, again, the ability for someone to access the application. So a low impact to availability would be something like you can temporarily remove their ability to access something. It's not like, a long time, or it's not going to be like permanent. It's just like a little bit of time that we can prevent the availability. Whereas a high availability is going to be like we could wipe out the access for a really long time, or I could delete their user and they no longer have access forever, right? So these types of ideas would be fairly serious in terms of availability. So that's the idea of the availability impact. And you'll see when I put in all of my details, we will get a score. And the score will be on a range of 0 to 10, where 0 means that there's really no vulnerability, and then anything above 0 is like a really low severity vulnerability, going up to the higher ranges, whereas a 10 is like extremely critical. Usually from like 7 to 10, we usually say is pretty high to critical based impact. So you see that as you adjust these different parameters, you'll get different scores, right? And it's helpful if we could provide these scores with our vulnerabilities so that we can tell people, how severe the vulnerability is that we actually found. And this is something that we'll do in pretty common practice when we're going through the process of doing penetration tests. We'll actually show and demonstrate this is the impact and scoring of this actual vulnerability, which will allow us to have just like a bit more credibility when we're going through that process. So we will revisit this idea as we continue on through, and we'll discuss different ways of writing up penetration tests and showing these different scores here. So that's the idea of how we actually evaluate vulnerabilities. Now, the final thing I want to talk about here is bug bounties. Bug bounties are programs where companies pay for vulnerability reports. So rather than having internal people do penetration tests, bug bounties allow for anyone to do a penetration test. And anyone who finds any sort of vulnerabilities can make some money from those vulnerabilities. There are a lot of Android-based bug bounty programs. And one of the major ones that I'll just talk about here briefly is the Google Play vulnerability program. The Google Play vulnerability program is a very large vulnerability program, and it applies to a lot of different situations. So I'll just show you which particular applications qualify for it, and then we'll talk a bit about some of the different things that are in scope for these kind of programs. So you'll see here that there's a long list of applications that qualify for this program. And generally anything with 100,000 or 100 million plus downloads will qualify here as well. And the idea is that if you can find a vulnerability in any of these different applications, you'll get paid money for it. And you'll see that the vulnerability levels can go in a lot of different styles, right? So for instance, if you could steal sensitive data and you could do it with no user interaction, you could make $5,000, right? So that's pretty good, you know? So we're able to find some really good vulnerabilities potentially and maybe even get some money out of it. So this is a general way that a lot of people in security make some money, is through these types of processes of finding vulnerabilities in applications. Now, this is just one of many. There's a lot of different programs that exist, things like, different bug bounty programs through either companies will host their own or they'll run it through some other external company that will be able to manage the bug bounties for them. And you'll be able to actually report vulnerabilities through those in order to get paid for those vulnerabilities. So my main goal here is really two parts, right? I want to show you how to do penetration tests on Android applications. That way you're able to actually do those if you're a professional doing, security-based jobs and you want to do some penetration tests on your Android applications. But I also want to show you how you do this in the context of bug bounties, because if you're somebody who isn't currently working at a company, this is a great way to make money. It's a great way to build up a resume in the world of security. And it's just a lot of fun to do, honestly. It's a lot of fun to track down and find vulnerabilities in applications. So with that, you have a general understanding of what a bug bounty is, what a penetration test is, what we're really going to be doing throughout this course as we're working through the process of Android bug bounty and penetration testing. So thanks so much for watching this video, and I'll see you in the next one.